Hello, everyone. Thanks for joining. My name is Animesh Singh, and this is my colleague Jason Anderson. We are part of IBM Cloud team, and we also have with us Egle Sigler from Rackspace, which is considered one of the co-founders of OpenStack, along with NASA. Now, today we are going to take you through a marriage, and no prizes for guessing who are the two partners in this marriage: OpenStack and Foundry. Now, what's the goal of this marriage? We want this family to grow. In other words, we want to deploy lots and lots of applications. Now, before I pass on to Egle to introduce OpenStack to us, I would like to know how many people here have either used or deployed OpenStack. That's roughly around 25-30% of the room. How many people have actually heard about OpenStack? Great, that's the reason you are here. With that, let me pass on to Egle, who is going to introduce OpenStack to us.
Thank you, Animesh. So it sounds like most of you have either heard or used OpenStack before, which is good because if you haven't heard, that means you have missed out on some great keynotes this morning. So what is OpenStack? OpenStack is really two things. One is a very huge and thriving open source community, and also a very large open source cloud platform. And you can think of it as infrastructure as a service for managing your compute, storage, and networking. As Animesh has mentioned, OpenStack was founded by Rackspace and NASA in 2010. Since then, it has exploded into a huge global community. And you can attend, it doesn't matter where you live, there's probably a meetup group. If there isn't, you should start one. So what is this OpenStack community? Since it was open source, it had over 2,000 developers making close to 80,000 commits. I think Foundry is probably an even faster track when it comes to community adoption and number of commits. OpenStack, very much like Foundry, is actually a collection of a lot of integrated projects. I think right now there are 12 or more official OpenStack projects, and probably more being proposed every day. I will not go over every single one of them, since this is just a very brief intro. I will go over the main ones: the compute, networking, and storage. OpenStack Compute, or Nova, and if you use OpenStack, you'll hear all of these code names all the time. So learning OpenStack means also learning a whole new vocabulary. So OpenStack Compute, or Nova, is the brains of OpenStack. It's the controller. It can be configured for high availability, fault tolerance. This is where your virtual machines get created. Now, what do you do if you have virtual machines? Just having them is not enough. You also need some networking. So for that, we are using Neutron, or OpenStack networking. Neutron is really your software-defined networking. It's one of the more complex and powerful OpenStack systems. And with it, you can create and manage networks, subnets, routers, load balancers, gateways, floating IPs, and more. Great, so we have VMs, we have networking. What else do we need? Storage. OpenStack has a few storage solutions. We're going to use Cinder. And you can think of Cinder as attached storage. It is great for performance-sensitive scenarios, and you can do snapshots, and all of that other great stuff. OpenStack provides all of its functionality through APIs and command line clients. However, if you're a user or administrator, you probably don't want to be making API calls or even using the command line clients if you just want to do some quick tasks. Lucky for us, OpenStack has a great dashboard. It's called Horizon, and you can have multiple users with different permissions set up, and whether you're a user or administrator, you can perform different tasks for managing your Nova instances, which are VMs, your networks via Neutron, or any of the multiple other OpenStack projects. So as I mentioned before, OpenStack is just a collection of a lot of open source projects that are extremely well integrated. If you have a need for something like databases or metrics or something else, there are projects for all of those. So if there isn't one, you can propose a blueprint and hopefully see it in the next OpenStack release. With that, I'm going to hand it over back to Animesh.
Thanks, Egle. Well, that's a great introduction to OpenStack. As Egle described, Rackspace has contributed so much to the success of OpenStack Foundation, and similarly, along with Rackspace, IBM has been also committed to the success of OpenStack Foundation. In the beginning of last year, IBM announced that all our cloud products would be based off OpenStack. IBM is one of the top 3 contributors in the OpenStack code base. And throughout IBM, we have around 380 IBMers who are actively working on OpenStack in different capacities. So OpenStack is great, and we need an equally strong technology in the platform as a service space. So we started investigating and found Cloud Foundry to be a great fit. Why? For exactly 3 reasons. Number 1, it's 100% open source like OpenStack, which means no vendor lock-ins. You can build tools and technologies around Cloud Foundry and easily port them across. Number 2, it fits in the true paradigm and definition of platform as a service. Developers go to Cloud Foundry with their code, and it's smart enough to detect their runtimes. You tell what services you need, it will provision and bind them together. And last but not the least, it has a very strong and vibrant community. More than 700,000 lines of code have been written, and more than 1,200 active developers have contributed code to the Cloud Foundry community code base. As you can see, both IBM and Rackspace are platinum founding sponsors of the Cloud Foundry community. Within IBM, we have around 42 IBMers who are authorized to contribute code to Cloud Foundry, and we have contributed to many components like Elastic Runtimes, Eclipse integration, etc. We have also open sourced many components, for example, WebSphere Liberty Java Build Pack, or Admin UI, performance acceptance tests, etc. And on top of this, we have built our platform as a service offering called IBM Bluemix, leveraging the Cloud Foundry code base. It allows developers to rapidly build, manage, and deploy apps while tapping into a growing ecosystem of services, not only from IBM, but from third-party service providers, as well as from the open source community. We have also integrated full DevOps lifecycle around it with Eclipse and browser-based tools. It's currently in open beta, and you can actually go ahead and try it at bluemix.net. So we have both OpenStack and Cloud Foundry identified. Now, what brings them together? How do they integrate? In this case, the integration is provided by BOSH. What's BOSH? It's a release deployment and lifecycle management tool for Cloud Foundry, and it has cloud provider interfaces to deploy Cloud Foundry to different IaaS providers like AWS, OpenStack, VMware, and very recently, Google Compute Engine. Now, Cloud Foundry also has certain requirements which need to be satisfied by the infrastructure as a service provider, and in this case, by OpenStack. It needs support for starting a floating IPs for inter-VM communication. It needs support for persistent disks so that application and runtime files could be stored. Custom VM configuration sizes need to be created for different components of Cloud Foundry like router, cloud controller, application nodes, etc. And there are specialized security groups which are needed to isolate management and application traffic. OpenStack satisfies all of these requirements. Now let's take a brief overview of how BOSH deploys Cloud Foundry. So BOSH takes a release, which is a collection of software packages, for example, PostgreSQL, MySQL, runtimes like Java and Ruby. And then there are stem cells or base OS images files, which BOSH converts into different VMs of Cloud Foundry. Tying all this together is a deployment manifest, which not only has information about the release and the stem cells, but also about the infrastructure as a service, where it is running, what are the network characteristics, etc. Bosch takes all these together and deploys it in form of VMs on the infrastructure as a service. So great, we have both Cloud Foundry and OpenStack identified. We know that they can integrate together. But the install process itself can be complicated. There are some manual steps involved, and you need domain experts in OpenStack, Cloud Foundry, Bosch to actually automate all that. And not only that, in our experience, it used to take us anywhere between days to weeks to actually get an OpenStack and Cloud Foundry environment up and running end to end. Now, we discussed that both OpenStack and Cloud Foundry have a very vibrant ecosystem and community. Now, let's see some of the examples how we can leverage into the power of this community and the technologies being built into it to actually go from a bare metal hardware to a running Cloud Foundry which is ready to push apps. For the first example, let's see how we can actually automate the installation of OpenStack itself within 45 minutes flat. Well, as I mentioned, OpenStack has a very strong and vibrant community, and tools like Chef have been written and open sourced which can be leveraged for this. For those new to Chef, Chef is a cloud infrastructure automation framework that relies on Ruby-based cookbooks and recipes. You need to tell Chef where your hardware is, the network information, and repositories where the files are stored, which need to be installed. And it will go ahead and configure the controller and the compute nodes for you. It will also configure the complex OpenStack network and also set up block as well as file-based storage for you. Now, let's take a look at our second example. So OpenStack is up and running. We need to discover a lot of this information from OpenStack, why it is needed. As I said, to prepare for Cloud Foundry deployment, we need to collect all this information in terms of where OpenStack is running, what are the network settings, etc. For this, we can actually leverage the open source FOG Ruby Cloud Services library, which can allow us to discover a lot of this information. Now, what all can we discover? We can discover a lot of things like security credentials, custom VM configuration sizes, network-related information like network subnets, network security rules, and typical things like IP addresses of your DNS, DSCP gateways, etc. So great way to collect that information in an automated fashion. Not only this, we can also leverage the same FOG gem to actually create a lot of Cloud Foundry requirements which are needed from OpenStack. As I mentioned, Cloud Foundry requires support for static or floating IPs, etc., network configurations, which could be done using the same FOG library. So for example, you can create security credentials. You can create custom VM configurations for different components of Cloud Foundry, for routers, cloud controllers, application nodes, etc. You can create network security rules. So after you have completed this discovery and setup using FOG, you will just need a couple of fields actually to deploy Cloud Foundry. For example, you'll need to tell how many application nodes I want. What's the domain name of my application? So that's great automation here. Finally, let's take a look at our third example where we can actually automate a lot of the Bosch deployment process itself. Now, before Bosch actually deploys Cloud Foundry, there are a couple of steps which need to be performed. For example, the base OS images or the stem cells, they need to be modified or created. And we can actually leverage the community for a lot of Ruby-based scripts which exist for this. Also, we need to generate this Cloud Foundry deployment manifest file. As I said, those deployment manifest files could be complicated and run into thousands of lines. If we can automate that piece, that is a huge gain. We can actually leverage Ruby ERB templating mechanism, and there are other technologies as well to actually automate that Cloud Foundry deployment manifest generation. And finally, a large part of the Bosch deployment process itself, in terms of uploading a stem cell file, deploying micro Bosch, uploading the Cloud Foundry core, services, and runtime releases, as well as finally deploying Cloud Foundry, could be automated and leveraged. So what we just discussed is that tapping into this powerful open source community, we can automate this whole end-to-end deployment of Cloud Foundry and OpenStack together and get repeated and consistent deployments in under 3 hours. By leveraging tools like Chef, Fog, Bosch, Ruby, and others, this is a huge gain in automation which you could have. And you could also combine them in different permutations and combinations. For example, you could deploy both OpenStack and Cloud Foundry together in one go, or you could deploy Cloud Foundry on existing OpenStack environments. So great, we identified both OpenStack as well as Cloud Foundry. How do they integrate? How can we automate that integration? So the marriage is complete, right? But what was the goal of this marriage? To deploy lots and lots of applications. In other words, to scale. With this, I will pass on to my colleague Jason Anderson to actually describe how we can scale Cloud Foundry and OpenStack together.
All right, thank you, Animesh. So now we have the goal of deploying lots and lots of applications. So what we need to do is start to scale this partnership, this Cloud Foundry and OpenStack partnership. So why do we need to scale, first of all? So number one, Cloud Foundry, as a technology and as a community, has been growing year to year. All you have to do is look at the conference turnout from this year to the prior year, and you can see the community is growing. And not only that, but Cloud Foundry really is matched for these born-on-the-web type of applications that have social and mobile components, which have really peaky, bursty network usage. So what we need to do is have an infrastructure that can handle that usage pattern. Then we also need the underlying infrastructure, OpenStack, to be able to scale in turn. So bottom line is we need Cloud Foundry and OpenStack to scale. So what's the first thing you do when you start planning your family and you want to grow? Well, you need to put together a budget. So here you have our budget, our sizing that we did for our initial Cloud Foundry on OpenStack and Cloud Foundry environment. You can see here the configuration of Cloud Foundry and how many DAs we decided we needed. And this is really for our first attempt at a large environment of 1,000 small applications. So we came up at the bottom here with the required resources that we'd need to put this environment into place. So we have our sizing, and we started going along and deploying Cloud Foundry, deploying OpenStack, and we ran into a number of configurations that we had to do. So both on the OpenStack and Cloud Foundry side. So let's first take a look at the OpenStack side. So first, as any distributed system, you need a good internal management for communicating between the different components. And so this internal communication has to be configured, the underlying bus technology. So let's look again now at the second point, which is optimizing the performance. In order to do that, we tell OpenStack to use a particular scheduler that ensures distributed VMs for Cloud Foundry to use. And then lastly, Egle mentioned that OpenStack, one of its great points, is that it's componentized, and you can scale each of the components individually, and you can customize it for the particular workload. As I mentioned, OpenStack is open source. There's a lot of other technologies we can leverage in the open source community, like Nginx, and we put together, our team here, an architecture that we presented at the OpenStack Summit of how to stand up an OpenStack environment that's highly scalable and works specifically for our workload of Cloud Foundry. And we have a link in the back of the presentation where you can go and look at that HA configuration. Great. So we've looked at how to scale OpenStack. On the Cloud Foundry side, what do we have to scale or be aware of when we're scaling up the Cloud Foundry environment? So first, we again need to look at internal communication. So all of these default config files are meant for small environments, so you stand them up, you test them out. But when we're starting to look at scale, you have to go in and change these parameters to ensure that communication for the internal system works correctly. Again, you want to make sure that your users of Cloud Foundry have a great user experience. And one way to guarantee that is to guarantee network bandwidth for particular parts of Cloud Foundry. So what we found, if you create separate networks for instance, your services and your Cloud Foundry core components, you can guarantee network bandwidths for each of those sets of components, which helps with the user experience. And then finally, Cloud Foundry, as an open technology, already has a great architecture for high availability. each of the individual components are meant to be scaled out. And so we don't have to do any extra work here besides size the environments for a particular workload. We want to have high memory applications. We want to make sure our DEAs are sized accordingly, for instance. Great. So now we know Cloud Foundry side how to scale it, OpenStack side how to scale it. And we put all these together with the automation that Animesh was talking about, and we have a working system. So with this presentation, what did we really cover? The three main takeaways. So one, Cloud Foundry and OpenStack is an 100% open solution. So that means no vendor lock-in. Plus, the communities are growing, and they have large industry support. Next, we can further leverage that open community in order to put together essentially an automated framework. So if we can use Fog, we can use Bosch, all these technologies to automate this process and make it easier. And then lastly, OpenStack meets all of the IaaS requirements for Cloud Foundry. And not only that, but Cloud Foundry and OpenStack can scale together, which provides a great environment and user experience as a company or as a user base starts to grow. So the bottom line is that Cloud Foundry and OpenStack is indeed a match made in heaven. But wait, we'd like to grow the family even more. So we're co-hosting some Silicon Valley meetups, so one for Cloud Foundry and one for Bluemix that we'd love to have you if you're in the Bay Area. So there's the links there if you want to sign up. We'll be there and hope to see you as well. Alrighty, with that, we'd like to ask if there's any questions in the audience.
I had a question.
Yes. Yeah, so actually, it may... Yeah, so that's actually a fairly recent development where they have ability for co-locating and setting that up. I know people are saying, is it Bosch when it goes to request VMs and starts turning those identities? So perhaps we can...
It's not a Bosch issue. This is an OpenStack scheduler issue.
The scheduler has ported scheduler hints for that for about 2 years at this point.
Right, so as Bosch doesn't take advantage of scheduler hints at that level is also a problem. So I know that's kind of been addressed. But because essentially Bosch puts the VM out there, or Cloud Foundry stands up or OpenStack stands up these VMs, and then Bosch turns those VMs into something. So Bosch needs to be aware that these two VMs are located on different hosts, and therefore I can safely put two cloud controllers, and therefore the HA is maintained. Yeah. So that's something, I mean, we can talk offline a little more about that too. Right, so we're using vanilla, we haven't changed any of the scheduler, and we have this problem of the affinity at this point. So we're looking to try to fix that in some of our next attempts at environments, yes.
So great, thanks all for joining, and you can find the slides here. They're already posted, and if you need more technical details about this, we have our talk from the OpenStack Summit, which goes into a lot more technical details around this.